Factor theorem is an important topic for leaving cert marks. So here today I'm going to give you a small brief about factor theorem and I'm going to do some exam questions. So the factor theorem says that if f of k is equal to 0 and f of x is a function, then x minus k is a factor. So for example, if there is a function called fx is equal to x cube plus 2x square plus 4x plus 3, okay, and if I say that f of 1 is equal to 0, this may not be true, this is just a sample. If f of 1 is equal to 0, I can say that x minus 1 is a factor of this cubic equation. Okay, the reverse is also true. Suppose if you say that x minus 2 is a factor, I can say that f of 2 will be equal to 0. So remember, there's a negative here, and here you will work with positive number. That is something which you have to remember. Okay. Now we will directly go into exam questions so that you will see how you can work this factor theorem and then you can get very good marks. Usually this come with 20 marks or 30 marks questions. So it is very important that you learn this, how to solve it, and it's pretty simple and the process is the same always. Okay. So here, if you read the question, x plus 4 is a factor. So if x plus 4 is a factor, f of minus 4 should be equal to 0. Okay, that immediately you have to remember. If x plus 4 is a factor, f of minus 4 is equal to 0. Now f of minus 4 means you are subbing in the value of minus 4 in this equation. So that is minus 4 cube plus q into minus 4 square minus 22 into minus 4 plus 56 is equal to 0. Okay, now you simplify this. You can simplify this as minus 64 minus, sorry, it is plus 16q plus 88 plus 56 is equal to 0. And then you get this as 16q plus 80 is equal to 0. So 16q is equal to minus 80 and q is equal to minus 80 divided by 16, which is equal to minus 5. You have proven the first one. Okay. Now, there's two parts over here, and see, you have to look at the question very carefully and find the three roots of f of x. So there are multiple ways you can find the three roots of f of x. You can either use a long division or you can add a quadratic equation to that and then solve it. In this case, I'm just going to work with the long division. So if you work with long division, x cube plus qx, okay, instead of q, I will put minus 5 now because you already have a value minus 5x square minus 22x plus 56 divided by x plus 4. This is what you have to do. Okay, so I will quickly do the long division on this side. So it will be x cube minus 5x square minus 22x plus 56 divided by x plus 4. So I hope you all know how to do the long division. So I will see how many times x will go into x cube, and that is x square, and this will be x cube plus 4x square, and then change the sign and subtract, and then that you will get as minus x square, and then you bring this down. So that is minus 22x. And then you see how many times this will go. X goes into minus 9x square, so it is minus 9x. So that you will get as minus 9x square minus 36x. Change the sign and simplify, so that is 14x. Then you bring the 56 down, so 56, and then you get 14 here, so it is 14x plus 56, and the remainder is 0. Now you have a quadratic here, x square minus 9x plus 14. Okay, so you have the quadratic x square minus 9x plus 14 and is also a factor. Now you need to simplify this, or you need to factorize this x square minus 9x plus 14, and that you will get it as x minus 2, x minus 7 is also a factor. So which means that x is equal to 2 and x is equal to 7. So the roots will be, you have a root over here which is x plus 4, which is like 4 is a root. Oh, sorry, minus 4 is a root, and then you have minus 4, then you have 2, and then you have 7. So you can write all the roots over here. Okay. Now going to the second question, I would really like you to pause the video and look at the question or read the question. So if you have f of x is equal to this and x plus 1 is a factor, again you will remember that f of minus 1 is equal to 0, and then you can work with this value, or yeah, okay, see, that is a statement which you need to remember. If x plus 1 is a factor, f of minus 1 is equal to 0. But in this question, f they are saying that x plus 1 is a factor of f of x. Find the three values for which f of x is equal to 0. So which means that you have to find the roots. That is what you need to do. Okay. Now in this case, again you can work with long division and then factorizing, or you can work with the other method like adding a value of x plus 1 and then putting a quadratic, and then you can work on it. But I would prefer long division now. So 2x cube minus 21x square plus 40x plus 63 divided by x plus 1. So here you will get 2x square, and this will become 2x cube plus 2x square. Then subtract, you will get minus 23x square. You bring the 40, so plus 40x, and then you will get minus 23x here. So this will become minus 23x square plus, no, not plus, minus 23x. Change the sign and subtract, so that will be 63x. Then you bring the 63 down, so it is 63, so plus 63, so this will be 63x plus 63, and the remainder will be 0. Remember, whenever it is a factor, the remainder will be 0. Now you can write this as x plus 1 and then this quadratic, so that is 2x square minus 23x plus 63 is equal to 0. Now it is factorizing this, so that if you factorize, you will get it as 2x minus 9 and x minus 7, and this factors remain, x plus 1 remains, so x is equal to 1. 2x minus 9 is equal to 0, so 2x is equal to 9, and which implies x is equal to 9 over 2, and the third one is x is equal to 7. So the answer will be this is minus 1, sorry, minus 1 and 9 over 2 and 7. Okay, so the same pattern for all the questions. These all are exam questions, so please have a look into this question. Now the third question, given that x square plus bx plus c is a factor of x cube plus b. Okay, so here there is one catch. So you have a quadratic here and you have a cubic here. So here also the long division will work, okay, but the long division might take a little complex route rather than doing the second method. So I would like to go with the second method here. So the method stems with the fact that if you have a quadratic, or maybe if you have a cubic equation, you can factorize it into a quadratic and a linear equation. Okay, so if you have a cubic equation, you can factorize it using you can factorize it into quadratic and a linear equation. So now currently we already have a quadratic, so I can write this as x cube plus px square plus qx minus 4, that is the cubic, that can be written as the quadratic is already given, so x square plus bx plus c, and then you can form a quadratic. Okay, so I'm sorry, linear. So what I'm going to do is I'm going to form the linear like x plus t. This is something which I am forming. Okay, so x plus t. Now what I can do, I can simplify this. I can simplify this directly, so I will simplify this left hand side. So this will be x cube plus t plus b into x square. You simplify, you multiply everything and then simplify this. Okay, and then you will get this as c plus b t times x plus ct, and here the left hand side remains the same, x cube plus bx square plus qx minus 4. Okay, so now we have same equation, cubic equation on both the sides. Now we can equate it. So you can equate the terms for x square, which is like 1 is equal to 1. You don't need to do anything. For x square, if you take this and this, so then it will become p is equal to t plus b. Then you're going to equate the x terms. So x terms is this and this. Okay, so then you will get q is equal to c plus bt, and then the final one is constant, so it is minus 4 is equal to ct. Okay, now with this, let's look back at the question. So you need to have c into p minus b is equal to 4. So how is that you're going to work on it? So here you need a minus 4 in here. So I know that, okay, I need to work with this. and I have a C in there, but I don't have a T in the answer. So what I have to do, I have to substitute it with, I have to eliminate T. So I'll take it from here where I can write this as T is equal to P minus B, P minus B, and I can substitute it into this equation. So minus 4 is equal to C into P minus B. Okay, now that's what we have it for this one. Okay, now the second one is 4B equal to C square minus QC. So again, you will look at these equations and see how you can modify it. So here also you don't have anything with the T, so you will have to eliminate T. So let me just take 4B. So maybe I will take the same one, minus 4 is equal to C into P minus B, and if you see there is no P here, okay, so you can alter it with something else, but you have Q here. Okay, so what you can do is or maybe I will just start with minus 4 is equal to CT. Okay, and instead of T there is no T here. Yeah, there's no T here. So what I will do, I'll take the second equation here and I will build Q T from here. So T is equal to Q minus C by B. Okay, so I can write this as minus 4 is equal to C into Q minus C over B. Okay, and this can be written as minus 4 is equal to CQ minus C square divided by B. Okay, now I can simplify this by cross multiplying. Minus 4B is equal to CQ minus C square. Now it is similar to the answer, but there's a negative sign, so I multiply all over by minus 1, so that will be 4B equal to uh, minus CQ plus C square, or it can be written as C square minus CQ. 4B equal to C square minus CQ. So this is very easy, very normal simplification. Only thing is like the factorizing one is what you have to remember, and you will be able to do this question. So this question was, I think this was 10 marks and this was 5 marks.